This presentation discusses and demonstrates the textures of sedimentary rocks. Textures relate to how the rock formed. Because each rock family forms in entirely different ways, each rock family has its own set of textures. Furthermore, a rock can have only one texture. Sedimentary rocks start as minerals and other rocks. These materials are broken up by weathering and erosion and then deposited. This is shown by the model called the rock cycle. The loose rock debris is called sediment. The sediment may be lithified. Lithified means turned into rock. This occurs through the processes of compaction and cementation. Lithification results in the material becoming sedimentary rock. Sedimentary rocks are classified into three divisions: clastic, chemical, and organic. Some systems merge chemical and organic into the chemical-organic division, or the biochemical division. Clastic means made of rock fragments, so clastic division rocks are broken pieces of rock that have been compacted and cemented together. Chemical division sedimentary rocks result from minerals precipitating out of water, and these are called precipitates, or by material being left behind after water evaporates. These are called evaporites. The organic division contain animal or plant fossils. Fossils are any evidence of past life. Fossils are more likely to be found in sedimentary rocks because these rocks form at or near Earth's surface in an environment that may preserve rather than destroy the evidence. The texture of sedimentary rocks relate to the divisions. Clastic division sedimentary rocks have a clastic texture. The clastic texture is further differentiated by the size and shape of the fragments that are glued together. Clastic sizes have four classifications. Large contains many fragments larger than 2 millimeters, or what are considered to be gravel. Medium contains predominantly sand-sized pieces ranging from 2 millimeters to 1/16 of a millimeter. Fine contains primarily silt-sized fragments ranging from 1/16 millimeter to 1/256 millimeter. The smallest is very fine, composed of clay-sized particles that are smaller than the 1/256 millimeters. The shape of clastic particles indicates the distance that the fragments themselves were transported before being incorporated into the sediment that was lithified to become the rock. Rounded fragments underwent considerable erosion that wears away and removes sharp edges. Thus, rounding shows these fragments were transported a notable distance. Angular fragments have not been subjected to this erosion process, so they have not been transported a significant distance. Of course, rock fragments range across a full spectrum from angular to round. The fragments that compose sedimentary rocks are also examined to see the uniformity of the particle sizes. This concept is referred to as sorting. As the energy environment or speed of the water transporting the particles decreases, the size or density of the particle that is dropped will decrease. If conditions are fairly stable, the same size range of fragments will continue to be deposited and the rocks will be well sorted. If the energy level fluctuates, this can result in variation in the sizes of the particles deposited at a site to make the rocks poorly sorted. Again, this represents a continuum from poorly sorted to well sorted. The texture of chemical division sedimentary rocks depends on the size or shape of the material or particles that make up the rock. Precipitates and evaporites have three textures associated with them. The first texture of chemical division sedimentary rocks is crystalline. This is composed of visible crystals. In the sample, note the crystal face reflecting the light. The second texture is cryptocrystalline. This is composed of tiny microscopic crystals. The third texture of chemical division sedimentary rocks is oolitic. Oolites are tiny rounded spheres that form by precipitation. A bunch of these cemented together makes for an oolitic texture. The texture of organic division sedimentary rocks is fossiliferous. These are categorized based upon the state or form of the organic material. Thus, 5 terms are used to specify the textures of sedimentary rocks, and additional properties of that texture provide important classification information. Clastic division sedimentary rocks have a clastic texture and are made of rock fragments that range in size from large to medium to fine to very fine. The rounded and angular natures are also considered. The 3 different textures of chemical division sedimentary rocks are crystalline, cryptocrystalline, and oolitic. The texture of organic division sedimentary rocks is fossiliferous.